Okay, let's just look at the third example. Okay, so same thing. The first thing that we have to find is a critical point. Okay, let's just begin with the function f that has been given in this question. So this is the function f. So in order to find critical point, the first thing that you have to find that is your f prime. Okay, let's just find our f prime. So this one we will get 12x cubed minus 12x squared. Okay, in order to find your critical point, okay, the first thing that you have to do is you have to let your f prime equal to 0. Okay, so it means that you will have here this actually equal to 0, so we have 0, 0 equal to this equation. So we have 12x cubed minus 12x squared, and do the factorizations. Okay, if we do the factorization, we will have 12x squared, and in here we remaining of x, and this one remaining of minus 1, and as a result we will have our x as 0 and x as 1. Okay, from here you're basically able to get your y. Okay, so when your x is equal to 0, so what happened to our y? Our y is actually, they ask you to substitute this x value into the original function f. Okay, so we have here f0. Okay, we will have 3 multiplied with 0 power of 4 minus 4, 0 power of 3, and at the end we have the 0 as the answer. So the first critical point that we obtain is 0, 0. Okay, then we have another one when x is equal to 1. Okay, when x is equal to 1, same thing, we're going to repeat the same process. We're going to substitute x equal to 1 into this function. So we will have 3, 1 power of 4 minus 4, 1 power of 3, and this basically give you minus 1. So we have another critical point that is 1 minus 1. Okay, so we obtain two critical points from here. So your critical point, that is basically 0, 0, and 1, negative 1. Okay, so we have done for the part A, so go for the part B. So part B says that you have to find the interval of increasing or decreasing. Okay, let me push it up a bit on this. Alright, okay, so in order to form the interval table that is in order to form the interval table of the increasing or decreasing, so you basically need the x value from the critical point. So our critical point here, that is we have two. One is 0, 0, 0, and another one is 1 minus 1. Or what we need here is just the x value. So we just have x equal to 0, x equal to 1. Okay, so imagine you have a number line, okay, a real number line. So we should begin with the smallest number. The smallest number that we can see is actually 0 and 1 here. You just put on the top of the table, okay, and it actually help you to form that interval table. Okay, so this is you have two number. Okay, that two number will give you an interval of 0, 1. All right, okay. And how about the next? The next is we only have one number here, so this is basically 0, and this must be a negative infinity. Okay, so this must be 1, 2, positive infinity. Okay, then we have test interval. Okay, so we have to put in some test value. Okay, just put any value that is in this interval. Okay, let's say I'm putting negative 1, and in this one I'm putting 0.5, and this is putting 2. You can put any value as long as it's in that interval. Okay, for instance, instead of 2, you can put 5, 7, whatever value that is in this interval. Okay, so again, to know whether the function is actually increasing or decreasing, what you have to do is you have to check on the sign of f prime. Okay, the sign of f prime is actually the same thing. You're going to substitute this value into here. So when you substitute this value into here, we will have a negative value. So we have a negative value. I have shown you how to get this on two previous videos, so you can refer to previous video how I get this. Okay, the concept will be basically the same. So we substitute 0.5 into f prime. So your f prime is this one. So substitute here. Okay, and basically this is actually give you negative, and same thing. Substitute this into your f prime. This is actually positive. So that is our result. Okay, and from here, so you're able to know what is your interval of decreasing and interval of increasing. Okay, interval of decrease is actually these two. So that is from negative infinity until 0. Okay, union with another one that is 0, 1. Okay, because you actually have union between these two intervals, so you can join them together. Okay, so you can join them together. It's basically negative infinity until 1. Right. Okay, so let's just look at the next. Okay, so let's look at the next. Okay, that is the interval of increase. So interval of increase, the interval of increase basically that is this one. Okay, so that is from 1, that is included 1, right? Okay, so it's included 1 from 1 to infinity, right? Okay, so that is the answer for part B. So if let's also get the part C. The part C is asking for the relative extremum. So means that you have to identify whether these critical points are maximum or minimum, right? Okay. Okay, so part C, we are going to find out whether these points are maximum or minimum. So the first thing you have to do is you need to find your f double prime. Okay, so let's go back to our f prime just now. Where's our f prime? Okay, we have our f prime here. Okay, so we have our f prime here. Okay, so now we're looking for the f double prime. F double prime is basically equal to 36x squared minus 24x. Alright. Let me push it out. Okay. Okay, I'll just need this. Okay, so now I want to know whether this critical point minimum or maximum. Okay, so what I have to do is I have to test each of them, right? So I have to test the first critical point that is 0, 0. Okay, so it means what? It means that you're going to substitute the 0, the x equal to 0 into this equation that we have here. Okay, so you have this. Okay, basically the answer is 0. Okay, so if you refer to the flowchart that have been given to you, okay, that it means that we have no conclusion, we have no direct conclusions when you're having f double prime equal to 0. Alright, okay, how about the next? Okay, let's just look at the next. Okay, we have 1 minus 1. Okay, 1 minus 1, same thing, we're going to repeat the same process. We're going to do the substitution. So we're going to have here, so we have 36, 1 squared minus 24, 1, right? So this is actually equals to 12, okay? So of course 12 is a value that is greater than 0, okay? So means that 1 minus 1 is actually a minimum point. So for 0, 0, we do not have a direct conclusion for it. So no conclusion. Alright, okay, so that is for our part C. So then we have to continue to our part D. They ask us to find the interval of concavity and inflection point. Okay, let's just figure out the inflection point first. Okay, so let's go for the inflection point. So in order to find the inflection point, what we have to do is we have to let the f double prime equal to 0. So in here, this is your f double prime. So let it equal to 0. So we have it is equal to 36x squared minus 34x. Okay, and do the factorization for this. We have 12x, and in here we have 3x minus 2. Alright, okay. So we will have x equal to 0, and we will have x equal to 2 over 3, right? Okay. So, okay, let's just see what happens when your x is equal to 0, okay? The same thing, we're going to do substitution, okay? We're going to sub the x into the original function. So the original function, that is 3x power 4. Your x now is 0 power 4 minus 4 minus 4 x. Okay, your x is 0. Okay, so power 3. So it will have equal to 0. So that is 0, 0. That is your first inflection point. Okay, let's just look at the next. We have x equal to 2 over 3. We're going to repeat the same process. We're going to substitute into the original function f. Okay, so we have to sub x as 2 over 3. Okay, when you do substitution, okay, basically we have 3, 2 over 3 of 4 minus 4, 2 over 3 power 3. Okay, and this is actually give you y is equal to minus 16 over 27. So we obtain another inflection point here. Okay, so your inflection point are 2. Okay, so the first, that is 0, 0. And the second, that is 2 over 3 minus 16 over 27. Okay, so we obtain the inflection point. The next task that we have to do is to find the interval of concave up and interval of concave down. Okay, so we need to find the interval of concave up and down. So same thing, you have to form a table, and that particular table is actually using the value that you obtain from the inflection point. We have these 0 and 2 over 3, so I'm going to put it on the top on the table, right? So just put it on the top of the table, and this will guide you on how to write the interval. So this is between two numbers, so you're going to write it as 0, comma 2 over 3, and on the side we have negative infinity until 0, and this is 2 over 3 until infinity. Okay, so try to put in some value to test. Okay, so for this interval, I pick -1. For this, I pick 0.2. For this, I pick 1. You can pick anything in those range. Okay. Okay. So same thing. I'm going to test for the sign. Okay. So we're going to look for the sign of f double prime. Okay. If we're talking about the concavity, we're going to using double prime. Alright, okay. The same thing, just substitute into here the -1 into the f double prime, you will have a positive. Okay, and substitute 0.2 into here, you will have a -1. Okay, and this is actually positive. So we have a table like that. Okay, then this actually inform you the interval of concave up and down. Interval of concave up it will be the combination of these two, that is negative infinity until 0, okay, union with another plus that is 2 over 3 infinity, and we have another one interval of concave down, that is 0 to 2 over 3. Okay, so done for the part D. So we go for the large part. So we're going to sketch the graph. Okay, so in order to sketch the graph, you need few information. Okay, the first information that we need is actually the critical point. Okay, we need to know it's either a maximum or minimum. Okay, so okay, this is a critical point, the relative maximum. For 0, 0, we have no conclusion. And for the 1 minus 1 is our minimum point. We just take these two, so I have 0, 0 as no conclusion. And I have 1 minus 1, that is our minimum point. And I have our inflection point, that is here. Okay, so we have inflection point, we have 2, so inflection point we have, that is 0, 0, and 2 over 3 minus 16 over 27. Okay, what else that we need? We need the table of increasing or decreasing, right? Okay, so we need that particular table. Let's just back to that table. So we need this table basically. So let me cut this table. Let me copy this table. Okay. I'll just put it here, right? Or here. Way better. Okay. Alright, okay. This is the table that I did just now for the part B, interval of increasing or decreasing. Okay. So this is the interval of the concave up and down, right? Okay, so let's look at the value that we need to have in the axis. Okay, so let's just draw out first on the axis. Okay, so you have the y and you have the x. Okay. Okay, let's look at the point, the point of x first. Okay, so the point of x that we require to have is 0, 0, 1, 0, 1, 0 back, 2 over 3. Okay, basically is actually here. We have 0. The next should be 2 over 3, right? We have to follow the number line. Okay, so this follow, okay, I'm just roughly only. Okay, so it's actually somewhere here, 2 over 3, and we have 1 here. I'm just draw roughly. Okay, so okay, let's look at the point that we have. Okay, so we have 0, 0. Okay, so 0, 0 is somewhere here. Let's say it's here 0, 0. In here we say no conclusion, but 0, 0 is actually appear in here. So basically the 0, 0 is actually under inflection point. Okay, so I'll just use the abbreviation for the inflection point, that is your IP. So this is your IP here. Okay, so next we have 1 minus 1. 1 minus 1, we somewhere here, let's say. Okay, so that is our minimum point. Okay, our minimum point, that is 1 minus 1. Okay, and we have this one. Okay, the IP, that is 2 over 3 negative it's somewhere here, negative 16 over 27. Okay, is another IP that is 2 over 3 negative 16 over 27. Alright, okay. So now after you have brought all the coordinates, you have three coordinates basically. Okay, then we're going to look at the table of concave. We're going to look at the table of increasing and decreasing. This is the table of interval of increase, decrease, and this is the concavity table. Okay, so okay, let's just look at this one first. Okay, this is basically tell you what. This is basically tell you that okay, we have minus for the first interval. Oh, okay, be careful. Okay, because we have an overlap here. We have an overlap of the number. Okay, you can see that for 0, okay, negative infinity until 0, that is this range, and 0 to 1, 0 to 1 is here. But basically in the middle we have 2 over 3 here. So we have 2 over 3 in the middle. So you have 2 over 3 in the middle that you have to consider. So we have 2 over 3 in the middle in this range. Alright, okay, so just be careful when you have to draw, okay? And then after 2 over 3, okay? So that is here, and then back to 1 to infinity, okay? Now let's just look at this one first, okay? We're going to do the drawing and comparing these two tables together, right? Okay, so let's look at the first one. Okay, the first one telling you that, okay, basically if you have the minus sign, you're actually having a curve that is going down, that is decreasing, okay, that is actually going down. But if you look at the table of concavity, it's actually a curve like this, okay? It's a concave up curve, okay, concave up, because plus stands for concave up, okay? So if you want to join this information, because it's actually the same interval, this is saying that you are going from negative infinity until 0 is decreasing, and the same table you have concave up. So basically if joining two, it's basically telling you that it's actually taking the halfway of the pictures you're actually considering here. It's actually decreasing, okay? So when you draw, it's basically like this, it's actually decreasing. Okay, you are actually decreasing, but you are using the interval of concave up. Okay, so how about the next? Okay, the next we have 0 until 1. Okay, 0 until 1 is basically this range, but be careful because we have 2 over 3 here, so you have to be careful with this one. The same thing, okay, so if you have a minus, it's actually decreasing, so basically you can expect that the curve is actually going down. Okay, but as I say that you have 2 over 3 in the middle, so let's just refer back to here. It is saying that, okay, you have a 0 until 2 or 3. This is in this range, okay? So what happened to here? It says that you may have a curve that is going down like this, that is concave down. So joining the message of this and this is telling you what? It's telling you that you basically have a curve that is going down and concave down. So going down, and concave down is basically this side. Okay, so pick the part. Okay, so we have here. It should be a smooth curve, right? It should be a smooth curve. Okay, we have a curve like this. Okay, then followed by the last one. Okay, so we're still under this range, but you have to continue here because 2 or 3 until 1 is in here, So according to here, okay, so you have a plus, so firstly you have a up, okay, you have a up, okay, concave up. This is a curve of concave up, but you have to consider here, okay, you have to consider here because it's still under the range of 0 to 1. It's still decreasing, but it's under concave up. So which part we should consider is actually here. It's actually at the half of this way. You have the concave up and you have going down. So we have here. All right, it should be smooth curve, but I didn't draw it nicely. Right? Okay, so anyway, it's concave. All right. Okay, how about this range? Okay, so you have from 1 to infinity. So this actually are things that you have going up. Okay, basically it's actually going up, but same thing you have to consider this. Okay, because it's actually it's almost the same range. Okay, almost it is actually consider overlap within this interval. Okay, so it's going up and it's under the cave of concave up. Okay, so it's actually in this curve. Okay, we're going to use this side. So in here, so you have 1 to infinity going up and curve up. Okay, so we have a curve going up. Okay, let's just double check on whatever that we have drawn just now. Okay, so just now it says that you have negative infinity to 0, negative infinity to 0. That is going down. We have a going down, right? Okay, the same thing. Okay, so let's just look at this. From 0 to 1, from 0 to 1, we have a going down, decreasing. So yes, we have a decreasing. The value will actually decrease. Okay. And then we have 1 to infinity. 1 to infinity, that is a curve that is going up. So a curve of going up. So we have this 1 to infinity, right? 1 to infinity, that is going up, increasing. The value is actually increasing. Okay, how about the curve of concave up and down? Okay, so you look at here. Okay, so we are talking about concavity. So this is actually the concave up, but it's actually from the negative infinity until 0, negative infinity until 0. This is the curve of concave up, concave up. That is here, concave up. Okay, and then we have the next 0 to 2 over 3, 0 to 2 over 3 is here. Okay, that curve is actually concave down, but from 0 to 2 over 3. So basically it's here, it's concave down, right? You have a curve like halfway, right? Okay, and next we have 2 over 3 to infinity, that is up. Okay, 2 until infinity, that is concave up. So 2 until infinity, 2 until infinity is concave up. 2 over 3 until infinity, that is concave up. So 2 over 3 until infinity is this range. So you have a curve of up like that, right? So time for our pictures for this example, right? Okay, so see you for the next class.